Okay, hello everybody. Today we'll be learning about thin films, and it's essential that when we learn about thin films, we know that when light reflects off a medium where its indices of refraction is less than the index of refraction of its reflected medium, the light itself gets 180 degrees out of phase from its original path. So, knowing this is very essential to what we're about to do, because if let's say you have an eye here, right, and then it, and then the eye is like, I guess, looking at this thin film, and then this is its indices of refraction of air, let's say, and this is the indices of refraction of the thin film. If light, if this is the normal, if we assume light goes like right on the normal, we could say that when the light goes here, some of it will get reflected back on the same line, but just so you could see it, I'll draw it on a different line. This is reflected light, and then some of it goes inside this thin film, and then when it goes inside this thin film, some of it gets reflected back from this thin film. So if let's say this eye could only see the reflected light, you would either see a bright spot or a dark spot based on if these two reflected lights are either out of phase or in phase. And how do we know that? Because of the path length difference. We know if this reflected light is in phase with this reflected light because of the path length difference. Now, knowing this, what we already know from this, right? If this red light like hits this thin film and then reflects back, if this thin film has a greater indices of refraction than this air, this in outgoing light, outgoing reflected light would be totally out of phase with its original path. And then the path that goes into the thin film, since, and let's say this is still N1, since this has a less indices of refraction than this, since this outside has a less indices of refraction than this, the reflected light wouldn't be out of phase with its the reflected light inside the film wouldn't be out of phase at all with its original path. So if this is totally out of phase with this, that means this will cause destructive interference. So the only way you could have constructive interference is if so the only way if you have constructive interference if you add a wavelength to this reflected light inside the film. I hope that's clear. You could only get a constructive interference if you add this half a wavelength to this film. So if you either add a half a wavelength, 1 and 1/2 a wavelength, 2 and 1/2 a wavelength, 3 and 1/2 a wavelength. So mathematically this could be written as m plus the whatever whole number time plus the half a wavelength you add to it would create this constructive interference. And as we know, what's the path length? If this film has a thickness, let's say d, its path length, the difference also equals 2d. Because the incoming light from this ray, the incoming light from this ray like this light travels 2 times the distance, 2 times the thickness, so its path length difference equals 2d. Now when we say the wavelength, since we're talking about this wavelength, of light inside the thin film, this wavelength of light is actually wavelength sub n, and this wavelength sub n equals actually the original wavelength of this light, the original wavelength of this light divided by the indices of refraction of this light. Okay, so in the next video I'll continue this since it's getting a little messy.